Hello student, welcome to the one more session of Analog and Digital Electronics. This is Vasant Naik from Canara Engineering College. In this session, we discuss Schmitt trigger. So in this session, we will discuss Schmitt trigger. So in my previous video, we have discussed what is a stable multivibrator, what is a monostable multivibrator, what is a operational amplifier, and important characteristics of the operational amplifier. So in this video, we will discuss Schmitt trigger. So a Schmitt trigger is a class of comparator which use the positive feedback. It is a comparator with the positive feedback is known as Schmitt trigger. The positive feedback is also known as regenerative feedback. So in Schmitt trigger, there are two types: inverting Schmitt trigger and non-inverting Schmitt trigger. So inverting Schmitt trigger and non-inverting Schmitt trigger. Now, so a comparator circuit with the positive feedback is called a Schmitt trigger. So comparator has got a Schmitt trigger. The output of the Schmitt trigger is either positive V saturation or negative V saturation. Both are in stable state. It's also known as a pure sine wave generator, square wave generator. And one more phenomena found with this one Schmitt trigger is hysteresis. So I will come to know about the hysteresis. This phenomena is not there in the comparator. That means Schmitt trigger can withhold the noise with respect to the signal. That is, Schmitt trigger has got noise immunity compared to the comparator. Now, so we will take the comparator. So basically, a ideal comparator is made of operational amplifier with the two input sources like V1 and V2. V1 is either one of which is a reference signal, either V1 or V2, with the bias voltage V plus and V minus, and the output voltage is V out. So this comparator will compare two voltages like V1 with respect to V2, and output is either positive Vsat or a negative Vsat based on the comparison. Now we will take two input signals, that is, let me draw here. So now here we will take two signals. One is V1. I will write here, one is V1, other one is V2. So these are both ideal signal, and V1 is greater than V2. V1 is greater than V2. Now output of the comparator. The output of the comparator when V1 is greater than V2, if I take this is the comparator, and this is the positive terminal, and this is V1, and this is V2. This is the negative terminal, and this is V2. If positive is greater than negative, the output of the comparator is you should get plus Vsat, or output is high. So the output voltage of the comparator should be something like it should be high. Now, suppose V1 is a noisy signal. Suppose if you consider V1 contain noise, then you can see, because of the noise in the signal V1, at 2 instant here V1 goes below V2, and the output of the comparator changes. The output of the comparator will get affected because of this noise. So in order to avoid this one, we are using Schmitt trigger. That means comparator is not old good for noise immunity. Comparator is not good for noise immunity because output will vary whenever there is a noise is there in the signal. So in order to avoid that one, we are using Schmitt trigger. So in case of Schmitt trigger, we are using two reference voltage that is called as VUT and VLT. VUT refers threshold voltage, upper threshold voltage, and VLT refers lower threshold voltage. So suppose in this diagram, this is the input signal. In this diagram, this is the input signal. So the output signal is, when the input signal is 0, the output signal is also 0. When the input signal crosses here at this point, upper threshold point, then output changes from 0 to high, and output will remain in that state as long as input remains above lower threshold point. When the input crosses below the lower threshold point, then output changes once again. Here you can see from high to low. Once again output changes from low to high when the input crosses upper threshold point. And this band between UT and LT, this is called as a noise immunity band or noise immunity band or noise immunity tolerance. So in this band, whether in this range, the tolerance in the variation in the signal is ignored. So this is the output of the Schmitt trigger. That is, when the output crosses particular threshold point, then it goes, when the input crosses particular threshold point, output goes high. When the input crosses particular threshold point like VLT, output goes low. That means input will be either high or low depending on the VUT or VLT. So we can say this one Schmitt trigger is has got immunity to the noise. So now definition of the Schmitt trigger once again, it is called a regenerative comparator. Regenerative means positive feedback with of comparator of positive feedback type. The output voltage changes its states whenever input voltage exceeds certain voltage level, that is upper threshold voltage or lower threshold voltage. There are two types of Schmitt triggers are there. So first one we will see inverting Schmitt trigger, and other one is a non-inverting Schmitt trigger. In case of inverting Schmitt trigger, the voltage source is connected to the inverting point that is negative terminal of the operational amplifier, and there is a feedback from the output to the input at the positive terminal of the operational amplifier. You can see here the feedback is connected from the output to the input at the positive point, at the positive terminal of the operational amplifier. So this is called as a feedback voltage. We have this voltage can be called as a feedback voltage we have. So and this is the input voltage. So input voltage source that is connected to the negative terminal. So similarly we can define inverting Schmitt trigger. In case of inverting Schmitt trigger, let me draw the diagram here. Inverting Schmitt trigger. So let me draw the diagram here. So I was explaining about the inverting Schmitt trigger. So in the inverting Schmitt trigger, voltage is we are giving the input at the inverting terminal. In case of non-inverting Schmitt trigger, we are giving input at the non-inverting terminal, and feedback also given at the point of non-inverting terminal, and inverting terminal is connected to ground, that is zero potential ground. This is the circuit diagram of non-inverting, and other one is the circuit diagram of inverting Schmitt trigger. There are two types of Schmitt trigger, inverting and non-inverting. So now, so students, this is the symbol of inverting Schmitt trigger. This is a symbol of the inverting Schmitt trigger. Here this shows This shows actually the transfer characteristics of the inverting Schmitt trigger. Transfer characteristics of the inverting Schmitt trigger. To draw the transfer characteristics, we need 5 parameters, that is V high or V sat plus, V low or V sat minus, and VUT upper threshold point, VLT lower threshold point. By having these 4 parameters, we can draw the transfer characteristic of Schmitt trigger, that is how the output behaves with respect to the input changes. So this is the diagram for inverting Schmitt trigger. For non-inverting Schmitt trigger, we have other diagram. I will show you that later. So students, now we will see the transfer characteristics of non-inverting Schmitt trigger. So let me write here, it is non-inverting Schmitt trigger, transfer characteristics of non-inverting Schmitt trigger, non-inverting. So here we are represented output voltage and input voltage. So when the input voltage is low or lesser than VUT is a upper threshold point, then output will be negative. When the input voltage crosses upper threshold point, then output will switch over from negative to positive. And when the input crosses upper threshold point and increases above the upper threshold point, output remains high. And input decreases below the upper threshold point, output remains high till input decreases below lower threshold point. When input decreases below lower threshold point, output will change from high to low, and output will remain low when the input remains less than lower threshold point. So this is the transfer characteristics of non-inverting Schmitt trigger. By taking the high and low voltage with equal and opposite polarity, we can shift this transfer characteristics to symmetrically to the x-axis, and by using reference voltage you can shift the transfer characteristics either to the left side or right side of the graph. I mean left side or right side of the this one x-axis. So this is the transfer characteristics of inverting non-inverting Schmitt trigger. Now how to represent the non-inverting Schmitt trigger? What is the symbol for non-inverting Schmitt trigger? The symbol for non-inverting Schmitt trigger is this is the symbol for non-inverting Schmitt trigger, that is, this is V in and this is V out, and here this represents the transfer characteristics, or we also call this as a hysteresis. Hysteresis represents the difference between hysteresis is nothing but is the difference between VUT and VLT, upper threshold voltage and lower threshold voltage. It is the difference between upper threshold voltage and lower threshold voltage. So as I explained you the transfer characteristics of non-inverting Schmitt trigger, this is the transfer characteristics of a inverting Schmitt trigger. So students, here you will see now how inverting Schmitt trigger works. This is the circuit diagram for the inverting Schmitt trigger. You can see from the circuit diagram, the voltage source is connected to the inverting point terminal of the operational amplifier, and there is a feedback from the output to the non-inverting terminal, and this is the feedback. This by using voltage divider rule, this is the feedback voltage. We can find out this feedback voltage we have at this point. So now when the input voltage is applied at the inverting terminal, and the feedback voltage goes to the non-inverting terminal, this means the circuit uses positive voltage feedback. If the input voltage at the inverting terminal is slightly positive than the feedback voltage, if the input voltage is slightly positive than the feedback voltage, then output goes negative VSAT. So output will be negative. And if the input voltage is more negative then the reference feedback voltage, then output will be positive. So input voltage is when the input voltage is positive, then output voltage is negative, and when the input voltage is negative, output voltage is positive. You can see. So this is the circuit diagram of the here we need to find out two threshold point. Voltage changes here. Output voltage changes from minus VSAT to plus VSAT to minus VSAT and vice versa. And these two vice versa are and these 2 points are called as upper trigger point and lower trigger point. Here you can see this is the upper trigger point, and this is the lower trigger point. Here you can see this is the upper trigger point and this is the lower trigger point. At this point the output changes either plus VSAT to minus VSAT or minus VSAT to plus VSAT. So what is the upper threshold point now? Upper threshold point is calculated by voltage divider rule, that is R1 plus R2 and VSAT. VSAT is the output voltage, that is we are going to give as a feedback. Similarly, lower threshold point is calculated once again R1 plus R2 minus VSAT. Now we know from the previous discussion, hysteresis represents the noise margin actually. Hysteresis is nothing but UTP minus LTP. So substitute this value. When you substitute this value, you will get this is equal to 2 beta VSAT. So here beta factor is nothing but R2 by R1 plus R2. So this is the expression about inverting Schmitt trigger. Now we will see the expression about non-inverting Schmitt trigger. The difference between inverting Schmitt trigger and non-inverting Schmitt trigger is here you can see here in the non-inverting Schmitt trigger we are connecting a voltage source at the non-inverting point. Here you can see the voltage source is connected at the non-inverting point, and that the inverting point is connected to the ground. When this one input is greater than positive is greater than negative, output will remain positive. When the positive is lesser than negative, output changes from VSAT to negative VSAT. Here you can see when the input is positive, the output is also plus VSAT. When the input is negative, then output will remain negative VSAT, minus VSAT. And this is the transfer characteristics of, as I explained earlier, non-inverting Schmitt trigger. Now we will derive actually the equation, because we have connected here the resistor R2 and R1 and voltage source. So VA is the voltage at this point, and the current flows through R2, entire current flows through R2, it will not go through the operational amplifier. So I is equal to V0 by R1, that is nothing but V out by R1. V out is nothing but VSAT by R1. So UTP is calculated here. R2 by R1 VSAT. R2 by R1 VSAT. And LTP is calculated here. In this case, LTP is minus R2 by R1 VSAT. This is LTP, this should be LTP. And hysteresis is nothing but UTP minus LTP. UTP minus LTP is nothing but when you substitute this one, you will get 2 beta factor VSAT. Beta factor is nothing but R2 by R1. So application of the Schmitt trigger. What are the application of the Schmitt trigger? The application of the Schmitt trigger is a digital to analog conversion, level detection, and line reception. So these are the application. Now we will see the this one, the problem related to the Schmitt trigger. Design a Schmitt trigger whose threshold voltage are plus 5 or minus 5 volt. Draw its waveform. So now here, so we have to choose the operational amplifier with the supply voltage plus and minus 15 volt. When the supply voltage is plus and minus 15 volt, then threshold voltage is 90% of the supply voltage, that is 13.5, and UTP is given plus 5 volt. Now we have equation UTP R2 plus R1 plus R2 VSAT. So substitute the value, UTP is 5, R2 by R1 into this one. We don't know R1 and R2, so you will get the value here, that is R1 plus R2 is equal to 2.7 R2 or R1 is equal to 1.7 R2. But assuming the one value, let us choose R2 is equal to 10 kilo ohm, you will get R1 is equal to 17 kilo ohm or 18 kilo ohm. So now the circuit diagram is here, this one. This is the circuit diagram here, you can see that because they have asked us to design the Schmitt trigger. So this is the positive feedback and we are using two resistor. One resistor we assume 10 kilo ohm, other resistor is 18 kilo ohm, and the bias voltage is plus 15 and minus 15 volt, that is the collector, and this one emitter voltage plus 15 and minus 15 voltage, and here you see this is the input voltage, and threshold voltage UTP is plus 5 volt and minus 5 volt. Here we found it is a mistake, so plus 5 volt should come here actually. Plus 5 volt UTP is, this is the plus 5 volt point and this is the minus 5 volt point. So when the input increases above, since it is a inverting, when input crosses above VUT, output goes from plus VSAT to minus VSAT. Once again at this point, when the input crosses below VLT, output changes from 0 to negative minus VSAT to plus VSAT, like this. So we will see the next problem. For the circuit shown here, R is given and R1 and R2 are given. Determine the threshold voltages if the power supply applied to the operational amplifier is plus 15 volt and minus 15 volt. So VCC is equal to plus 15 volt. VSAT, so it's we assume here VSAT is equal to plus 15 volt and VSAT VSAT minus is equal to minus 15 volt. Then we have R1 and R2, and we know the expression VUTP and VLTP. Substitute that value, corresponding value, you will get the value, that is threshold voltages you will get 35.2 millivolt and 35.2 millivolt minus millivolt. The next one is for the circuit shown here below, the circuit, find the value of R1 and R2 if the supply voltages are plus 12 volt and minus 12 volt. Also hysteresis is 6 volt. So VSAT is given plus 12 volt and VSAT minus is minus 12 volt. Hysteresis is 6 volt and you need to find out the value. So we know VH is nothing but hysteresis is nothing but this expression. Hysteresis is given by this expression. Hysteresis is given by this expression. Substitute the value. When you substitute the value, you will get the value of resistor R2 and R1, that is 10 kilo ohm and 30 kilo ohm. Now design a Schmitt trigger circuit with UTP 4 and LTP 2, both are positive. Assume VSAT is 14 volt. So VSAT is 14, UTP is 4 and LTP is 2. Now we know this expression UTP and LTPs. So hysteresis is VH. So you need to find out first VH. VH is equal to UTP minus LTP. When you substitute the value 4 and minus 2, you will get 2. So you will get 2. Substitute this value and substitute the corresponding value. You will get the value of resistors R1 and R2. Now design a Schmitt trigger circuits with UTP minus 2 and LTP minus 4 volt. VSAT is 14 volt. So we know hysteresis is nothing but UTP minus LTP. So when you substitute this value, you will get 2, and we substitute the we don't know the value of R1 and R2. So we got this expression from substituting the value, this one, we got this expression. Now if you assume the one resistor is 10K, other resistor will get 130K. 130K. For the Schmitt trigger, R1 is 3 kilo ohm, R2 is equal to 1 kilo ohm. Calculate UTP, LTP, VH. Assume saturation voltage is 12 volt. So saturation voltage is 12 volt is given. That is V sat positive, V saturation positive, V saturation negative is 12. R1 is there, R2 is there. Then we know this one expression. V UTP is equal to, this is the expression, substitute the value, you will get UTP point is 4 volt and LTP point is minus 4 volt, and hysteresis width is given by this equation. So substitute this one, you will get hysteresis value is equal to 8 volt. So students, with this I completed, I explained Schmitt trigger. So in the next class we will see active filters. Thank you.